Causal inference is the concept of statistically estimating causality between input and output data, in other words, the relationship between the cause and result. It is also called causal inference in statistics. It has been attracting attention in recent years partly because researchers who measured the effect of a policy using causal inference won the Nobel Prize in economics. Conventionally, the main technique in statistics has been to analyze the correlation of multiple data. Analytical methods such as testing and regression are used to describe the robustness of the relationship between data. However, these techniques can show correlation, not causality. Therefore, causal inference that estimates causality has come to attract attention. Examples of analyzing causality include estimating advertising effect. Assume that exposure to an advertisement increases the purchase rate of a product, for example, ice cream. In this case, exposure to the advertisement cannot completely explain the result, the purchase of the product. It may be because more stores were offering discounts or simply because the temperature was higher, rather than because more people were exposed to the advertisement. The causality can be estimated by knowing what would have happened if the exposed people had not been exposed to the advertisement. The difference in the effect between exposed and non-exposed people can be considered to represent the causality. In other words, the key point of causal inference is how to estimate what would have happened if something had happened otherwise. This method can be used to estimate what would have happened if a patient who usually takes medicine had not taken it. Another example is to estimate what would have happened if residents who are subject to a policy if they had not been. In order to analyze causality in a statistical manner, the causality should be estimated based on the change in a group, not the change in one person. In the example of the advertisement, the effect is estimated by comparing the percentages of people who purchased the advertised product between the treatment and control groups. The treatment group is the people who were exposed to the advertisement, and the control group is the people who were not. By using the data of the control group, who were not actually exposed to the advertisement, it is estimated what would have happened in the treatment group, who were exposed to the advertisement if the group had not been. It is generally said that women are more likely to be exposed to advertisements, and thus it is not possible to determine whether it is because of the effect of advertisements or because of gender. To address this, the treatment and control groups are compared under the same conditions except for exposure and non-exposure to the advertisement. Specifically speaking, by correcting the bias of the subjects in each group, the treatment and control groups can be compared with no bias, and the effect in the treatment group can be estimated. However, it is not practical to make all conditions the same. Therefore, it is important to identify factors that may affect the purchase of products such as gender, age, occupation, and income, and to correct the bias of these factors. To summarize, the key points of causal inference are as follows. 1. Estimate the effect, namely, what had happened if something had happened otherwise in the treatment group based on the results obtained from the treatment and control groups. 2. Correct factors of samples in the treatment and control groups, so that all factors are the same except for a certain factor. 3. Extract important factors that may affect the result, as it is not possible to make all factors the same. The key point of causal inference is to statistically correct the bias of the subjects included in the treatment and control groups. The following are two typical methods for correcting bias. 1. Difference in differences. This is a method to correct the bias of subjects by considering the level before an event occurred. To estimate the advertising effect, the increase in the purchase rate of the exposed group is compared with that of the non-exposed group. Then, the effect of the advertisement is estimated by calculating the difference. Assume that the graph of the result describes that the product purchase rates already differed from each other before the advertisement was displayed. It can be said that if the purchase rate of the exposed people was originally high, there is a bias that many of the exposed people already had stronger purchase intent, even before they were exposed to the advertisement. The approach is to minimize the bias of the subject by considering the prior level and estimating the effect based on the increment. Difference in differences corrects the bias of the people in each group by considering the prior level. However, this method cannot be used if the only available information is that people purchased the product after being exposed to the advertisement. 2. Propensity score. Propensity score is used to correct bias by homogenizing the composition of the samples included in the effect measurement and control groups. In general, the effect measurement group, who were exposed to an advertisement, has a higher percentage of women, and the control group, who were not exposed to an advertisement, have a lower percentage. Ideally, data such as product purchase rate need to be measured after the ratio of men to women is made equal, 1 versus 1, in both groups, to estimate advertising effect based on the differences. In other words, the groups can be correctly compared by calculating the overall results after giving lower weight the female samples in the effect measurement group. Specifically, if the percentage of women in the effect measurement group is 60%, the inverse of that, 1 over 0.6, can be multiplied as a weighting factor, while the control group can be multiplied by 1 over 0.4 as a weighting factor to correct sample bias in the two groups. By estimating the probability of belonging to the effect measurement group, the effect can be correctly estimated. This probability is called propensity score. Specifically, a regression analysis is performed to obtain the propensity score of samples by using attributes such as gender, age, and occupation as explanatory variables. By employing the inverse of the propensity score of samples as a weighting factor for each sample, the results of the effect measurement and control groups can be compared homogeneously, which allows for a correct estimate of the causality. This technique using propensity scores is called inverse probability weighting. However, in order to make a correct estimate, the correct factors for homogenizing the two groups must be selected. In addition, the probability of belonging to the effect measurement group, that is, the propensity score, must be calculated correctly from these factors, and there are still many challenges. Causal inference, which is used to identify causality rather than correlation, is still under study and is the most advanced subject in statistics. It is also true that it is difficult to completely identify causality because of the constraint that a certain amount of data and randomness must be ensured. Regression analysis, which observes the relationship between two sets of data, includes the term analysis, whereas causal inference, which analyzes causality, includes the term inference. This may be symbolic of the difficulty of grasping causality.